Hi everyone, happy to see you here. It is our 7th user meeting. I'm glad that you're sticking with us. So as you know from the email, we have changed the format slightly. So now instead of every 2 weeks, we are going to meet every 4 weeks. Hopefully the content will be even more interesting as it was before. In the previous 6 meetings, and I have it on the screen, we've covered pretty much all the basics of our platform. So now we are shifting more towards platform extensions or particular user cases or solutions built on the platform. And of course, we will keep you updated regarding all the new functionality, core functionality, and other features that we keep producing. So today we have 3 topics and 3 speakers. The first one is an extension done by Alex, our new data scientist who recently joined the company. The second presentation is about an application that was built by one of our customers and collaborators. I think it's going to be really interesting. And the third one is about a new backend scripting engine that we have recently built and are already using in one of our other customers. Having said that, Alex, the floor is yours. Please proceed with your presentation. I'm making you a presenter right now.
Okay, I'll go first. That's some pressure. Okay. Yeah, I'll share my screen now.
Can you please speak louder?
Yeah, sorry. Can you hear me well?
Yeah, I guess now it's okay.
That might be the reason why.
Yeah, we can't really hear you at all, guys.
Does this help?
Yes, it's better.
Okay, beautiful. So before I begin, I should mention that I've really been working with Andrew and Grok for around 2 months now. So I didn't really have any knowledge of JavaScript beforehand. My primary coding environments were R and Python. Yet I was able to create 2 packages actually. One of them is a data imputation package, which we'll probably demo a bit later. And the other one called ChaRPy you'll see today. And so it just goes to show how modular and well easy to develop these packages really are. Given that I've had really little experience with JavaScript, I was still able to successfully pile up the code and create this system. Another thing I should mention is why even create this specific package. There was a certain request for it, and if I understand correctly, people require this functionality to be able to port the viewers into, for example, RStudio for their other external projects, or if they want to include it in some scientific work. As we know, sometimes you have to be very specific and show the code that you've used. So for example, if you've been using our platform to do the graphing, but you still want to recreate that in R or provide that as a reference, you could use that. You could use this functionality to do it. So we'll begin with scatterplot. I have implemented a number of plots into this package. I won't be demoing all of them today, but I'll show the most important ones, which are the scatterplot, the histogram, the bar chart, and the box plot. So beginning with the scatterplot. Let's say this is a very simple version of it. We're just plotting height against weight. Let's say we just want to port that to R. By clicking on this tab, what we get is first of all our code that produced the plot on the right, and the corresponding plot in Grok that we just transferred into R. So what happens here is without going into the details, is that we have a JSON map, essentially, that, there it is, that maps all various plots to sort of ggplot functions, which are sliced together to produce the final version of it. And all of this is done dynamically, it's done automatically. So all you have to do is just switch the columns, maybe choose some parameters available through Grok Viewer, and all of the substitutions will be carried out seamlessly and implemented into this little chunk. And just to, as a proof of concept, we could just copy paste it as well and just maybe shove it into R for the sake of it and just run it like that. Yeah. And we're going to get the exact same plot. But to extend our Grok functionality, we didn't want the user to copy and paste this into R. Maybe he just wants to see straight away if this works or it doesn't work. And so for those purposes, we have something called scripting viewer, which is essentially an R graphing environment, which takes up the produced code and then renders the plot, and then shows it to the user so he can compare the two. Yeah. So moving on, let's try to play around with some parameters. So for example, let's say that we want to change our color coding to sex. By running the, yeah, okay, so this happens sometimes, but this is something I'm working on to fix it now. Yeah, so now we can see that there's a new color coding implemented into our code. And we can see that it does exactly what it's supposed to. So you could do the same with other parameters like size, for example. See, if you run that, it also gets implemented into the code and then rendered in the R scripting viewer, as you can see on the right. So let's continue with something a bit more interesting, which is the histogram. I don't know why it does that. Give me a second. Just reload the page for a good measure, just to make sure all the updates are functional. Yeah, let's open up histogram. And let's choose, for example, what number of bins we want, like 37, 36, 35 looks good. And then we can run it. And as you can see, we get the same plot on the right. And we can also dynamically sort of zoom in into specific areas by using this sliding window, which is really, really interesting. The only minor issue is that the ggplot renders 20 bins, renders 35 bins within this window. So even if we reduce the amount of bins on the left-hand side, it still renders 35 within this plot. But this kind of gives you a good ability to zoom in into the data and see the finer detail. And what is really amazing as well is that everything happens dynamically. So this communication just happens underneath the hood, so to say. And so really by just adjusting this sliding window, all the commands are directly fed to ggplot, which then produces the output. So everything is connected. And this is just a demo of this functionality, but what is planned in the future is to add a similar connector, I guess, to connect all the various plots together. So for example, you'd be able to do the same with say, scatter plot. Once you plot it, you'd be able to also change height and weight in the previous window that I showed you, and it would also dynamically change on the right-hand side where the R scripting viewer outputs its graph. Let's have a look at bar chart as well. This is one of those things that I did. Here we have a number of aggregation functions, and I made sure to implement every one of them. So say I want to look at skewness, for example, and we can run that as well now. So as you can see, it works exactly the same for every plot. So there was some tweaking that I had to do beforehand, but ultimately it's basically the same plot. And you can then, just double check, you can then copy paste it again into the to our studio and run it, and it's just going to give you exactly the same image. And then you can upscale the resolution if you want to by dragging. Yeah, so this is pretty much it. I'll show the box plot as well, just to reiterate on what I've shown so far. So let's plot this against weight, for example. And let's use a different color coding for our marker color. Let's say we want it to be coded by sex again. So if I run this now, it produces a really nice, beautiful plot again. And I want to stress that, as you can see, all these little changes that I did to Grok Viewer parameters, all of them are yet again implemented into the R string, and all of them are shown on the right-hand side. There is also some, I guess, extended functionality that I implemented into my R code. So we'll be improving our platform in the future. We'll be making improvements to our graphs specifically, and all of those improvements will also transfer to this package, and all of that will be available soon, hopefully. We also have additional functionality for trellis plots, core plots, and line charts, but that takes just a bit of tweaking as of yet, so I won't be able to show it just now, but it's coming along very, very soon. Thank you very much for your attention, and this is where I should stop. Andrew, do you want to take over?
Yeah, sure. Perhaps it's
Or if there's
a good idea to open up to questions.
Oh yeah, sorry, yeah. If there's any questions, just feel free to ask. I'll be happy to answer.
What would be an example of real-life usage of this?
Just as I mentioned, people that would like to port their calculations to, for example, RStudio, or they would like to reproduce the same graphs. So imagine the person is not really, good at using R language, for example, and he's just starting out, and he really wants to, for some reason, one or another, to use RStudio. So he'll just extract this code from here and then implement it into his R code, and it will work just the same. Or again, as I mentioned, it's important for documentation. So some companies, they require that the every plot that's produced is accompanied by the code that produced it. And so to do that, we also provide this functionality, so it's easier for people to follow up on their documentation and to be able to write everything out clearly.
Thanks. I just wanted to mention that actually this request came independently from 2 or 3 different companies, but every time it was from statisticians. So a few times from non-clinical statisticians and from clinical statisticians as well. So I'm assuming tools like R and Python are getting more popular in that sort of community. And in that case, they can use our platform as a tool for exploratory data analysis, but whenever they need to sort of cast their findings in stone, yeah, they can export it as an R script.
Any more questions?
Okay, great. Thanks a lot, Alex.
Yeah, I'll just quickly mention as well. This was more of a demo of me, as a new Grok user that has no previous experience with JavaScript. Being able to develop and deploy this within a couple of weeks, really. So the learning curve wasn't too steep, I would say, and it just goes to show that there is, people should probably invest their time into learning these little things, and it's really easy, and all of it can be really implemented seamlessly into this platform where people without any programming background can use it. So I think that's just like a highlight of the user friendliness.
Awesome. Thank you. And yes, you're right. Next time you will likely be presenting your another package which handles imputation of missing values. That one is a lot more ambitious, I would say.
Thank you.
All right. Let's switch to our next presenter. So, Dmitrii, would that be you or
Yeah,
Andrey?
yes, it's me.
Okay.
Let me try to. I still cannot.
Yeah,
share my
I'll have to transfer the.
Okay.
Mm-hmm. Yeah.
So
So,
how
Alex, transfer it to Dmitrii Petrov, please.
advanced sharing options? Multiple participants can share simultaneously. I guess that's the option that I want. Wait. All participants. There we go. Are you able to do it now?
Okay. Yes. Okay. Let me see.
Beautiful.
Okay. Can you see my spreadsheet?
Yes.
Okay. So I'm from JNF, which abbreviates as Novartis Institute for Functional Genomics, located in San Diego, and we are a part of a big Novartis organization. So we have been evaluating Datagrok for a while to determine how this platform can be used for our future in-house applications. And our goal at this stage has been to write features prototypes for our most challenging application called MedChem browser, actively used by our scientists. Our typical MedChem data set consists of a few thousand of compounds shown here as rows and a few hundreds of assays shown as columns. And different assays, they belong to different types, and all of them have complex data format. As a result of that, each of these cells that you see has multiple internal parameters. And for our scientists, it is absolutely imperative to display all those parameters in one grid cell, because they consider them as one object or one data point. And they developed this kind of mentality during many years. For example, this in silico assay has several parameters, including well-known Lipinski violations, molecular weight, and this IC50 assay, they have parameters like medium IC50 value, fuzzy sign, standard deviation, percent efficacy, last tested date. And as you can see, not only we display those parameters in a single cell, but we also paint them differently. For example, a Lipinski violation value right here, we consider it good when it's less than 1, when it's more than 3, it's bad, and something in between is neutral. And as you can see, we use different colors to highlight that fact. But perhaps the most important feature here is dynamic layout of cell content. When we have that much data, as I mentioned, our scientists need to look at as many cells as possible at once. And that's why for any given size of these cells, each cell tries to fit as much information as possible, while the priority is given to more important parameters. So for example, if I reduce the size of the cell, right, you see how certain parameters start to disappear. And at some point where there is almost no space left, only the critical ones will be displayed. So same idea applies to this. Let me go back a little. Same idea applies to this column header. Usually we have very long assay names, and we wrote a special custom cell renderer that basically intelligently wraps those long names while preserving the integrity of individual words, so that keeps them readable regardless of the cell size. Let me show you what I mean. Lots of interference. So if I change the size, you see how dynamically those the display of those names changes. And all this kind of display functionality was achieved by, as I mentioned, by writing custom cell renderers to make the grid viewer display our data the way our scientists understand them. But this specificity not only impacts the way we display the data, but also the operation we perform on them. For example, sorting. That's why we introduced the default sort feature achieved by clicking on the column header. And it's supported by all the assay types, as you see. And also we introduced this so-called customized sort feature using the context menu. So if I make a right click, you see the option I'm given to sort. Like I said before, IC50 assay has multiple parameters, but for us, it only makes sense to sort by medium IC50 values and last tested values. It doesn't make any sense by sort by fuzzy sign or by standard deviation. Nobody ever does that. That's why those options are not even presented in that context menu. So as you can see, all this functionality I showed you is really column type dependent. In future, we need to add more custom column data types representing different things and requiring specific interpretation. So how can we simplify the process of adding new data types so that Datagrok would understand them the way we need? I will switch to the slides right now. Oh, this is so many things. Oh my God. Okay. Can you see my slides?
Yes.
Okay. So to be able to add new column types, we introduced the notion of this generic semantic type class that teaches Datagrok visualization understand any custom data objects like this IC50 object shown on the right. And it provides services to display object in a grid cell or on scatter plot. It provides the information about how many display and sort options are available, what is the default sort, how to filter object of that type. In other words, this semantic type answers the question not only what makes sense to do with our data, but also provides instructions how Datagrok visualization should handle it. This JavaScript semantic type class is essentially a top-level interface to be implemented by any custom types. It basically repeats everything I have just said, but only using JavaScript language jargon. So different users will use different groups of functions. For example, grid viewer will be using those related to display options and sort options, while scatterplot will need to know how to convert our custom object into floating point values in order to be able to plot them on an XY domain. This slide shows how this generic semantic type works on the application level. So we installed our derived column types into the application's main data frame. which is in turn installed into the Datagrok application tier, which understands the structure of generic semantic type. And for each viewer, this tier subscribes to the services like mouse dispatcher, send, cell rendering listener, context menu notifier. And when, and when the corresponding event is fired, this tier, what it does, it queries our custom types and installs the returned information into the response of the fired event. For example, if I make a right click on this in silica column, just a second. Yes, when I make a right click, the context menu will go to the data frame and find the corresponding semantic type. And it will ask it a question. What are the name of the sort options for your type? And the answer will be Lipinski violations, molecular weight, and CLOP. Same way, if I click on the header of this type, it will request the compare function for in silica type. And this Datagrok occupation tier will use that compare function to sort our custom objects. And of course, when a cell rendering event is fired, the request will be paint me this cell. And the response will be this image with intelligently packaged and highlighted parameter as one entity, even though somewhere on the database level, this object is represented by a bunch of primitives from different columns. You can see that all this low-level interaction with Datagrok UI is hidden in this application tier. And adding new custom types becomes an extremely simple task for end users. And as of today, we provided generic semantic type support for Grid Viewer with all the features I just showed you. And we plan to teach scatter plot, filters, and other visualization to understand the specificity of our data. That will be done in future. In short, this is kind of it for this quick update. What we have done with the Datagrok, and Andrey and his team provided us outstanding support. Some of the features were not available out of the box in Datagrok, and we keep adding them. We find issues and we solve them. So it's a wonderful collaboration, and if no major distraction will be in front of us in the near future, we will write many great features and functionality. So Andrew, back to you.
Thanks, Dmitrii. Yeah, let's open up to questions. It was quite an interesting presentation. I'm always amazed about how deep you guys went, even without our really close support. Yeah, you developed most of that application even before we knew that you were doing it. Very impressive.
Thank you.
Yeah, that is really impressive. A lot of functions. And just one question. Did you manage to compare Datagrok with other systems, and why did you choose it?
So in-house, we have, I mentioned we have this MedChem browser application, and it's written in Java. It's extremely interactive and fun, extremely interactive application, and provides lots of features, mostly like in Spotify. But our goal recently is to rewrite this application using modern web client and preferably using JavaScript. So we've been looking for kind of solution for that, and Datagrok came as a natural choice for that because it contains lots of visualizations, lots of functionality, but some core functionality that we need is kind of missing, and that's why we are trying to kind of bridge the gap and write the functionality that we need, and that way we started to work with Andrew, and that was kind of amazing experience for us and very interesting.
And what are you? I'm sorry if I missed that. What are your closest plans to maybe some kind of particular features you want to add?
So yes, we so
right now, this was a proof of concept thing for us. We wanted to understand if it's possible to do what we wanted to do with the Datagrok, right? And it looks like it absolutely is, and we are very impressed with the functionality and freedom that it offers. So we will be developing many different applications on this platform, and both ourselves and with collaboration with the bigger neighbor organization. But so as of right now, we are just developing this object-oriented approach to data, because the data comes from the server as primitives, and we are just trying to make it work both to keep that, to be able to take advantage of all the functionality that Datagrok offers out of the box, and at the same time have this more object-oriented view for our customers. So that's what we are working on right now, just the technical side of the thing.
And obviously, I can add that, yes, we need to teach Datagrok visualization, basically to understand our data types. So the most natural next step would be to add more visualization to that level, specifically filters, because it's an essential component for our scientists, and it needs to be done a little differently than a Datagrok offers out of the box. But this will be done a little bit later when we sort out other issues.
Yeah, what I'm especially excited about our collaboration is that in the future it's possible that there will be open source components produced by either us or you or anyone else that the whole community will benefit from. And while most of the functionality that Dmitrii, you were describing perhaps is very specific to JNF or Novartis in general, things like filters and other components, some of them are pretty generic. So I'm really looking forward to us working together on exposing it to the community.
Yes, I can add only one thing, that it may look like it's JNF specific, but in reality is not. We never write code like that. We always write a very generic component, which is 99% of the code, and then we spend a little time, that 1%, to customize the way we need. But all the libraries and everything are pretty generic. If you take all our Java MedChem browser, it's pretty much Spotfire, but even on a deeper level. So yes, lots of the functionality, lots of libraries can be used as generic libraries for Datagrok in future. Yes.
Yeah, we are completely on the same page with our team regarding our approach to writing software, not surprisingly. Okay, great. Any other questions to Dmitrii? I see Dima has joined. I'm surprised, Dima, you don't have questions. That's your domain.
Yeah,
All right.
I joined a little bit late. I missed the first part.
Oh, I see. Well, it will be available on YouTube. I'll send you a link. It was pretty interesting. Okay, great. If there are no more questions to Dmitrii, Dmitrii, thanks a lot. It was really, really interesting.
Yeah, my pleasure as always.
Yeah, and then I hope you have the privilege to share the screen.
Yeah, let me see if I can take over. Yeah, here we go. Can you see my screen now?
Yes.
Yeah.
Pretty good. Okay, so hi everyone, and today I'm gonna tell you about some new functionality that we've recently added to Datagrok, and this is support for Octave. So I'm gonna show you how you can utilize that support and what are some important details of using Octave through Datagrok, and how does it actually differ from Matlab in daily use, since Matlab is a pretty popular tool in certain industries. And then I actually gonna talk a little about my recent experience that I had pleasure of having in the recent weeks, using this Octave support to actually build a solution for one of our customers, and I'm gonna talk a little about that solution. So let's go to Octave, and since today it's available in the public version of Datagrok, since yesterday actually, and now along the other scripting languages that we already had, you can now use Octave. And as far as you can see here, the very simple script that you get when you create any script to start with is just a script that outputs the number of cells in the data frame. So now I'm gonna just run the default script in Octave to show that it works. Yeah, so you need to first take a table, and with that button I create the default table, which is cars. Now I can run the script on cars, and to see the result, I need to open the console. That I can do with using the tilde button, like you used to do in some computer games. So this is the output of the script, and this is the way you can see the outputs of the scalar values in the scripts and strings as well. But now I'm gonna do some more interesting stuff with that script. So the problem here is that Octave doesn't really have a concept called data frame. So to say, you cannot access columns of the table by string names, as you used to do in other scripting languages like Python and R. So the way we deal with that here is that we support as the data frame the very basic data structure of Octave and Matlab, which is called a cell array. And I'm going to show you how you can specify a cell array and return it. So now, instead of having an input, I'm just going to have no input, but instead of this int output, I'm going to specify the data frame output, and it's going to be called df. And the df is going to take the following look. So in Octave, there is a peculiar syntax that you have to just get used to, and this is just the same as it is in Matlab. So generally speaking, Octave inherits all the basic properties of Matlab. The differences come in details.
that they're going to show later. But pretty much all the language core functionality, including numeric arrays, cell arrays, etc., are the same. Yeah, so here I'm going to specify the data frame. It's going to have a header with column names, which is going to be A and B, and then it's going to be the 2 rows, okay? And that I'm going to save and run, see what happens. Yeah, so here we go. This is the properly formed data frame. So as far as you can see, the role of column names in Octave data frame I put here in bold parentheses, is just cell array. And in that cell array, the first row is going to be treated by Datagrok as the header of the columns. And
then, excuse me, may I make a suggestion? If you can you just briefly describe what is Octave, what is its relation to Matlab, and why we started working in that direction overall? Of course, without naming any names and companies, just so that people have more context, because I'm not sure if everyone on the call knows what Octave is.
Absolutely, yeah. So. Octave is a pretty much open source alternative to Matlab, whereas Matlab, I believe that actually everyone knows about Matlab, but this is the pretty popular environment for mathematical calculations and mathematical applications in general. But it's, well, it's commercial and it's expensive sometimes. So the alternative here is to use Octave runtime environment and language, which is almost one-to-one compatible to MATLAB language. So MATLAB scripts you typically find in the form of the .m file, and then what you could try to save your costs on using MATLAB is to take your script in MATLAB and run it in Octave. And Octave, you can actually install it and you can try running your scripts in that interactive environment on all the popular operating systems. And for us, it was the task to embed Octave support into Datagrok. Yeah, so here the way you access Octave runtime is the same as you're used to with Python, R, etc. But there are some important differences that who already used Datagrok with Python scripting would value knowing. Yeah, so Andrew, I hope that answers your suggestion. But please, if any one of you have any questions about Octave, I will gladly answer. You can just ask on the way. I wonder if any one of you have ever had experience with Octave previously.
Well, I used it a little bit.
And what was the context of that use?
Well, my first encounter, actually, I think Andrew also had the same encounter as when we took the machine learning class. It was a while ago, and later I actually used that to run some calculations involving sparse matrix factorization, similar things.
Yeah, it's actually a good point. The popular Andrew course on machine learning is using Octave, as the main runtime to show the data science. And my own experience with Octave was actually the same course as you mentioned, but also some applications of time series analysis and digital signal processing. Somehow it turned out that digital signal processing is very popular to get done with MATLAB. But since you don't have immediate access to MATLAB, people started to use Octave for that purpose. And that is due to some really well thought through libraries for DSP in MATLAB ecosystem that was later ported to Octave. So yeah, MATLAB and Octave certainly have use in different industries. And for us, it was not just to implement that support for one customer, but actually to make it widely available for all those who need Octave. Yeah, so that's pretty much the Octave overview. And then I'm just gonna go back here and show you some other things that you can do. Though I know that it's not that today we have just developers in the meeting. We have people of very different qualifications, but it's just to get the overall idea how you access and use scripting in Datagrok in general, not just in Octave, is something I just gonna show a little more here. Yeah, so this thing with the header, is there anyone who has a question about this? I mean, I know that some of you have definitely used Datagrok in the past. Yeah, so please.
So in this particular case, Octave runtime runs on the server side, right?
Yes, exactly, and the same do all other scripting runtimes. So the way it works is that we have the special server instance that hosts and runs these runtimes using something called Jupyter kernel. So to say, I can also give you a brief pointer. So this is a really handy way to utilize scripting languages today. Basically, you can run R scripts, Python scripts, Octave scripts, Juda scripts, other scripts in a homogenized fashion using a Jupyter runtime. And Jupyter notebooks is something that many of you have actually used and heard of our support for Jupyter notebooks from the previous meetings. But the truth is that you could actually use Jupyter for many other scripting languages, including Octave. And that's pretty useful because, truly speaking here, I only spent like 3 days adding support for Octave to Datagrok. And that is because I just had to utilize the internal APIs of Datagrok that interoperate with Jupyter kernel on the server side. And Jupyter kernel basically arranges the compute script jobs. And the result of the job may be a text output or image output. So here, I could also show you how it works with images. I just prepared this small script that shows one-dimensional interpolation, 2 methods for interpolation using Octave libraries. So this is the way it's gonna run. So so this is the same picture that you might have gotten from the octave.org help. It compares 2 kinds of interpolation function. One is specifically designed for periodic functions, and the other one is generic. And this is also very handy thanks to Jupyter kernel. Jupyter kernel provides us with the graphical output, and here you just do regular Octave. You don't call any special kind of plotting facilities. You don't need to manage files, etc. It's really convenient, and people who get used to working with Jupyter will appreciate that way of work.
I'm just wondering if there exists even a theoretical possibility of Datagrok interacting with locally installed applications that run scripts. Like, for instance, if you have R shell or Octave installed locally, is there any technical trick that would allow Datagrok to interact with a locally running application?
Actually, there is a theoretical possibility to make it, but we don't have it right now. So I see the theoretical way to do it. So just install something from Datagrok on your local machine and make this interaction possible. But this is only theoretical right now.
Yeah, I do not know how much sense it would make, whether it's worth pursuing or not at all, and whether whether there's any kind of scenarios where the users would actually would need this functionality. It seems to be handy, but if it's like really cumbersome, it may not be worth it.
Actually, we have the Datagrok Docker image for this compute virtual machine instance, so you can install it on your local machine, and all of these things would work without internet and without sending data to our compute virtual machine.
Yeah, we will certainly providing and supporting this option that Alexander mentioned, where you run the computation service on your machine and then you don't need anything else. We will also be providing Datagrok as a standalone application. This is all is coming, but yeah, we are not ready to commit to any timelines regarding that yet, but it's certainly coming.
Yeah, it may be convenient. Yeah, for example, not even with like full-blown applications like R shell or something, but with some utilities. For example, some people might want to use for chemical structure drawing. They might use to they may be used to ChemDraw or some application or BioVia Draw or whatever, and would want to simply sketch chemical structures locally. And I actually have an example of how a web-based application can use our sketcher. I mean, people are using it at J&J. So it's controlled from within a web page and actually interacts with a locally running sketcher.
Yeah, so the way it's organized today, I'm just going a little more technical here. So this is called a CVM machine that hosts the runtimes, and conceptually, it really should be same way if you want to organize that locally in your machine and then connect to that local machine instance. And I mentioned Jupyter notebooks, the Jupyter kernels, but it's also possible to support other runtimes that are not supported through Jupyter, maybe even separately, not through Jupyter at all. Thinking of Matlab itself, some companies might want to stick with the original Matlab and continue using it through Datagrok, and that should also be possible. However, it's much more handy to actually support open source alternative for us as well, but also for the customer who will definitely find the benefits of open source technology that replaces Matlab in a sort of one-to-one way. And I'm going to tell a little more about that soon. Yeah, but that's it. So please, any one of you who'd like to try some Matlab / Octave scripts in Datagrok, please go on. And now I'm going to proceed to the interesting customer case that actually utilizes this support. The application that we've developed is a very interesting one, since it organizes the quite complicated workflow that has to do with production lines and equipment that is used to produce to produce the product. And the application that was originally available was developed in Matlab, and it had a graphical user interface also built in Matlab. As I mentioned, Matlab allows to build full-blown applications, and that was done. And the problem with that application was that it required a lot of manual work. People had to go on and populate their inputs to that application. Actually, these are not even one application, but several. And they had to manually populate the inputs from many data sources. And these are really different data sources. One is the database, classical database that is hosted internally at the customer side. The other data source is XLSX spreadsheet with multiple tabs that is maintained by some teams inside customer. And the third data source is, so to say, REST API. And we've built an app that allows for automatic population of that inputs. And not only because we actually had to go through the original Matlab application and convert it to Datagrok. And I had a pleasure of doing this for perhaps several weeks. And that was really straightforward because in Datagrok, all these mentioned data sources you could easily use through the means of the platform. So in here you could connect to the database, and then you could also add the web service endpoint and query it, and you could even cache results, which was actually the case for the customer application, since some of the queries are really long running to access that database, but the data being queried is not changing frequently or not changing at all. So it was very handy to utilize the Datagrok caching functionality. And also, coming back to the scripts, it's important to note that any script you create in Datagrok, you could later utilize in the apps that you build on Datagrok. And that what was also done for one of the data sources in the form of REST API. Originally, we just took the Python script written to demo access that endpoint and just ran it through Datagrok and populated the results into the user interface of that application. So really, Datagrok allows for all these, at first sight, complicated operations to be done easily in just a few lines of code because the facilities are available. And the interesting part was to match some functionalities of Matlab to Octave. And in particular, that has to do with the optimization libraries that minimizes functions, the cost functions given certain criteria and boundary conditions. And truly speaking, it is possible to do in Octave in the same way you could have done it in Matlab. But there are important details when it comes to the actual methods that I use to optimize the function. And to name a few, we floated around sequential quadratic optimization SQP method, then the interior point method that is default in Matlab, and Levenberg-Marquardt method that is default in Octave. So we had to match what was the best method for that particular application we worked on, and then make sure that that one method runs the same way in both Matlab and Octave. And the one method that worked the best and ran the same way was SQP, and that was the method of choice. And I recommend the same method to try out if you have such a need to run optimization problems in Octave. Yeah, so right now this application is in the last third part of the development process, and the customer is going to take on the development to actually continue on their own, since now we are supporting them in the development. Yeah, so please, any more questions about Octave support and functions, scripts in general in Datagrok?
So if someone needs a specific version of Octave for some reason, I do not know why, say the latest version, how easy it is to update the engine on the server side?
Yeah, it is a good question, and it's certainly doable to support several versions of Octave, and also the related question is to support certain versions of libraries for the script. This is something that I hope to highlight in one of the next community meetings. What I'm talking about here is to make it possible to select certain versions of libraries for your particular script and run it in a localized environment. And this is something that will come out of the box in the foreseeable future. It's actually already available, but it's more like out of the trenches. Some details are not available yet, but that will come soon. And then the next logical question is to support different runtimes on the server side. That is also something we're gonna provide for. Not as of now, since now it feels like the last version of Octave is actually the best, but maybe it's not true for Python. In Python, for instance, you have at least 2 branches of the language, so Python 2 and Python 3, and some companies might want to go with 2, others might want to go with 3, but this is manageable.
Well, looks like Python 2 has died already.
Yeah, I hope so.
Yeah, I'm curious, what would happen if you misspell something in the header? For example, if you misspell Octave, how would Datagrok handle it?
That's a good question. So this is crucial. You need to have that parameter here. If you don't, it won't recognize. I think it will default to some first supported scripting language, because otherwise, what will be the way for Datagrok to understand what is the scripting language you want here to be run?
Now, I'm just wondering how friendly the error message is gonna be if you really misspell it and try to run it.
Like you say, like this, right?
Yeah.
Well, we can try. I mean, why wouldn't I try that? There is something to improve, definitely.
Yeah, that's what I thought, because I noticed that quite a few error messages are very confusing, for users. And I intentionally asked you to do this, and I expected something like this.
I know. That's a good intention and good execution. But what I can say here is that this is something we are looking into right now, because we want to improve the error messaging in Datagrok. In one of the next releases, it would be important to notify the user what's the origin of the problem encountered, and make, in that particular case, and not only in that case, in some other cases, a more user-friendly informational message to start with. There are other cases that might happen. You might have error in the script, and in that case, you might want to get as much information as possible from Jupyter backend to know where the problem is in the script, and other things like that. Basically, usability of scripting is something that we are looking into as well. But thanks for the question.
Mm-hmm. Yeah, and I just like 10 minutes ago I mentioned the possibility of potential possibility of using an external chemical sketcher. I think it'll be extremely useful actually if you somehow manage to like enable this function. It'll be one of the most useful external application interactions for chemists and medicinal chemists. If they could use somehow, instead of that little embedded Marvin sketch or whatever, or whatever sketch is implemented in JavaScript, you know, they could use full-blown ChemDraw or BioVia Draw or Marvin or whatever that are used to, you know, to sketch chemical structures. It'll be extremely useful.
Yeah, we will certainly be providing a number of ways to sketch molecules. It's actually on our roadmap, and I believe there are people listening on this call who are also very interested in that. But Dima, it looks like you also wanted to have the capability to use a native sketcher, and I'm not sure if that's a particularly useful idea because JavaScript sketchers are evolving pretty quickly. So we will have different sketchers, but they will all most likely be JavaScript based, unless there is a really important need that is not covered by them.
Yeah, I'm not sure. I mean, we can ask specific users. You can sort of conduct a poll, but I noticed that people are just used to their favorite sketchers because sketching chemical structures, non-trivial chemical structures, is a pretty elaborate task. You know, it's not like throw a couple benzene rings on the canvas and you're done. If you may have some peculiar specific features of each sketcher that you're used to and you really need even certain functions and available in certain sketchers. Like for instance, Marvin comes with a bunch of chemical transforms and structure checkers, and that's a Java application and it's installable locally. Many people use it, and then ChemDraw is sort of de facto standard, and people may have tons of structures already sketched in ChemDraw, you know, and they would just want to open their sketch and simply interface it with Datagrok, or they would want to be able to say double click on the structure cell in Datagrok and pop it into local ChemDraw. I think it's here. This is for the kind of chemistry related usages that will be quite handy to be able to do so.
Yeah, I agree with that. It's yeah, people are very sensitive regarding both sketching the molecules and rendering them, and we will be providing different multiple options for either. And actually, as yeah, you were talking about that, I just thought that it is already possible to implement what you mentioned, sketching it externally via an extension if necessary. So
yeah, that's right.
This should be solvable.
Okay then, so thank you for watching, and if there are any questions, you can follow up on the community forum. Anything else, Andrew, we want to add to that meeting?
Yeah, any other questions perhaps?
I have the traditional question. You probably can guess what I would
No, Dima, don't ask it, please. No, we have not released the change here regarding the UI for joining tables. It's coming though. Okay, great. Any Other questions or ideas?
Yeah, so hi, Andrew. This is Nirali. Hi, Dan. Thanks. Great presentation.
Hi, Nirali.
Hey.
Hi, Nirali.
Hello. Yes, so I wanted to just ask what would be the, just from the question, that Dmitrii was asking, just a very basic one. I know Octave is a great tool and, we get the error messages too when we try to like code it here, but I'm just trying to think, what's the best recommendation? Like when we want to code in Octave, would you recommend that we use this interface to start coding, or would you rather recommend that there is like we do it in an editor and then maybe publish it, or maybe use the repository for getting the code in here and then maybe try to run it? How what I mean is sometimes you get those suggestions while you are kind of trying to code directly into an editor, etc. So just trying to think of that sort of a thing.
Yeah, that's a good question, and my personal experience with development scripts through Datagrok is that I actually combine using both local environment like that, as you mentioned, has some handy features like tooltips and other hints that this editor doesn't have yet. It might very well happen in the future that there will be more out of the box IntelliSense functionality in that editor. But since now it's really straightforward to draft and try out the script locally in Octave or R, and then copy paste and run it here and see what happens. Then when you proceed with development applications, scripts are parts of your applications usually, and then you typically start to version that scripts through repository and publish packages with applications through that repository. And then again, it's really now there are 3 parts, but it's really straightforward. So you have the repository instance of the script that you can open locally from a copy of your repository on your computer, and the same script will be available through Datagrok that application carries from the repository. So you basically work with the same script, which you synchronize by using the shared repository, right? So I don't think that anything should limit one to either coding the script in Datagrok or local environment. Actually, both are used, and the same Alex can confirm. Whenever I see Alex working on his beautiful impute package that you should see soon, he uses that approach. He tries things in RStudio, and then he also tries things and replicates them in a Datagrok script editor, and runs the script as part of the of particular workflows that that user might want to use through Datagrok.
Perfect. Yeah, no, that's what I wanted to get out of that then, is that syncing, even if the syncing is possible, it's very easy. Perfect. Thank you so much, Dan, for answering.
Thank you, Nirali, for the question.
Yeah, how would you reference a local Datagrok table in Octave script?
Yeah, so you would like to open the local Datagrok table, or to start with, it's just like that. I mean, let me start over with the new script. So in here, this thing, data frame table, is basically the local table that you might choose. You could also open another table by its name as data frame in the script, and then you use this data data frame, data table as cell array of Octave. I'm just leaving that pointer here since it might be important for these who will watch that video later on, and they will see, aha, actually they don't have a data frame in Octave, they just use cell arrays. That's useful. So basically cell array is just a polymorphic multidimensional table where you can combine different types of cells like string cell and numeric cell in one array. You can also
so you just use the first dimension as the placeholder for column headers, right?
Yeah, the first row I use as the placeholder for column header. Yeah, and then if you want to add the column to your row cell array, typically what happens is this: you want to just add a couple of headers to something that is produced from some numerical method, and numerical method typically produces matrices or numeric arrays. And then what you have to do is just you have to call num to cell. I'm sorry for being very technical here, but this is a really nice pattern that I used a lot. And yeah, you just need to take your array that numerical method produces and concatenate it with the header. And you just need to make sure that the dimensions are aligned, and that's it. Yeah, so that's how I do. And that's pretty much everything you need to know about data frames in Octave on Datagrok.
So essentially this table identifier becomes a cell array, right?
Yeah, exactly. So you get cell arrays and you emit cell arrays.
It may actually be useful to have an option of simply gate name matrix without the headers, because as far as I remember, cell arrays and Octave are pretty inefficient computationally, so the numerical methods actually need matrices anyway.
Yes, that's right, and that's what happens in the real application. You just convert as soon as possible. You kind of extract the meaningful numeric data from cell array, and then you just manipulate the numeric array, and then you stuff it back into that very handy syntax with cell array again, and that's useful when you need to structure the output. For instance, you have the first column that stores names of parameters, and you have a bunch of them, and then you have the values of parameters in the second column, and you just emit that as cell array, which is data frame that is consumed by Datagrok. Yeah.
Yeah. What happens if your current table that you're trying to use here contains data types that are not representable as Octave types?
I think that for most of the types, I actually chosen reasonable mappings. So we think about date time, for instance. We think about different types of integers and floats, and we could take this offline, but the mappings are pretty reasonable. If you look at how Octave people deal with date time, for instance, you will realize that they want a certain representation which is very simple, like not to say simplistic, but very simple one in Octave, and we just convert it into that representation and back. Yeah, but
what about custom objects?
That's a good question. That's a good question I need to think about. I don't have an immediate answer. But in here, the custom object should probably be converted to a nested cell array. That might be the best option.
Either that, or perhaps the most common denominator would be a JSON object, so a serialized string. But yeah, it can all be managed on some level.
Yeah, I don't think that's kind of practically very important, because Octave is usually used for numerical methods, and I don't see like a lot of use on trying to deal with complex objects from Octave. The important thing is that if the current working table happens to have those objects, the script wouldn't fail. It would just say be converted into some kind of string placeholder or some kind of just something that simply is not used really, but just doesn't make the script to fail if the table contains such objects.
Yes, it's not the question of implementability. It's rather what is the most idiomatic choice in terms of Octave. So to check that, I need to look around a little bit and see what Octave people, MATLAB/Octave people do to represent these objects, and then provide the most idiomatic, Octave idiomatic solution that fits well with Datagrok facilities too.
Okay, so we are running close to the end of the meeting. I think we have 3 or 4 minutes left. So I just wanted to thank, first of all, the presenters. Great presentations, Alex, Dmitrii, Dan, and yeah, also to everyone who joined the conversation. Thanks a lot. It's always great to be with you. I hope to see you again in 4 weeks during our next presentation. So hopefully we'll have more guest speakers. It's always a pleasure. With that, thank you everyone, and see you later.
Bye-bye.
Yeah.
Bye-bye.
Thank you. Bye.
Bye-bye.